Right, over to you, Andrew. Thank you.
Thank you, Charlotte. Hello, everybody, and welcome to the little presentation today on the this new personal detection device we're about to put into the market in the coming days. We'll kick off and get into it. Basically, people who don't know Weldclass, were founded in 1979. We are a reasonable sized player in the Australian market, in the top five actually in the Australian market. We sell welding machines, safety equipment, welding consumables, filler metals, the whole lot. One of our big focuses over the last 3 years has been welding safety, especially, so PAPR systems, extraction systems, all that kind of gear. We're based in Tamworth, New South Wales. That's our head office. And we have warehouses both in Sydney and Perth. And we have staff all across the country. In actual fact, we're coming to you today from our office in Melbourne, in the northern suburbs. So, as I discussed, we do lead in fume control and all things safety for welding. We go to a lot of trade shows and we do a lot of work with end user customers, TAFE colleges, and some major industries to talk to them about their issues with fume. And over the last 12 months especially, we've seen there's an opportunity to develop our own personal fume monitor, and that's what we're going to be talking about today. So obviously, back on the 18th of January 2024, things changed. The laws were introduced in a cohesive effort by the states and territories of Australia to reduce the level of fume to 1 milligram per cubic metre exposure time over an 8-hour time-weighted average limit. So how do you measure that is the key. So how do welders, how do business owners, how do they look and see without getting an occupational hygienist in every day to review what's going on in their workshops? So that was a significant change in our market. And I think now Australia is one of the leading countries in the world for really regulating fume exposure. But at the moment, it's called a workplace exposure limit, a WES, and it's over the 8-hour time-weighted average. And it went from 5 milligrams down to 1 milligram per cubic metre. The welding fumes are now classified as a Group 1 carcinogen, and we all know that carcinogens or carcinogenic materials can cause cancer. So that's official around the world. So we've got to do something about it to make sure that we take those nasties out of the workplace. Employers or a person conducting a business undertaking, which is the PCBU, which is the terminology used in the legislation, are now required to ensure that workers' exposure to welding fumes doesn't exceed the limit. Obviously, PPE is one part of that solution to fix a problem, but it's not the first place an employer or a PCBU should go and start at. You should start at the hierarchy of controls and then try and eliminate fume. And we'll talk about that next. So Safe Work Australia have released their standards. It's very easy to access online. And it talks about elimination is the first place we should start. So look at the risk management process, identify the hazard, assess the risks, control the risks using the hierarchy of control, which is on the next slide, by the way, and then review the measures. Air monitoring is actually required in certain situations, and that asterisk means that basically where you have a team of people and you have a health and safety representative, and that can be either management or employees, and if they asked for air monitoring, then legally you have to do it. Now, there are thankfully employers in this good country of ours who don't wait to be asked. They actually go off and do it because they're concerned for their own health as well, which is great. And that they're concerned for the health of their own employees. So it's just to be aware of that. The results from air monitoring can also indicate how effective your workplace controls are, such as ventilation systems, opening doors and windows, for example, overhead extraction, all those type of things you may already have in place. Implementing effective control measures according to the hierarchy of controls is the best way to proceed. So this is the hierarchy of controls. So eliminate exposure and the risk if you can altogether. So in some cases, welding is replaced with riveting, screwing, fitment of different metals, glues, believe it or not. Substitution, that's part of that, glues and using other ways of reducing welding. You can isolate workers, so you can put them into specialised welding cells with very good fume extraction to basically remove all the fume so it doesn't go into the rest of the workplace. Because this legislation is not just about the actual worker, the welder with the torch. It's also about the fumes that are going into the wider workplace. Engineering controls is the LEV, local area ventilation, MIG guns with fume necks on them connected to vacuum systems. We're talking about forced dilution and ventilation. And again, natural ventilation comes into it as well. You can actually engineer to have certain louvers on windows that open up and force air into a workshop as well. Administrative controls is all about education, looking at risks and the consequences, and putting in, I suppose, procedures and safe working practices that address all these hierarchy of controls. PPE is the last one on the list. So once we get through all the rest, and by the way, our friends at WorkSafe will be asking employers and PCBUs if they've actually gone through a hierarchy controls and if they can actually prove that. So it's very important to remember that. So PPE is the last point, and obviously there's a lot of PPE out there in the marketplace, whether it be from Weldclass or Speedglass or other big players in the market that are selling for example, PAPR systems. I will talk about other companies in the market today. I'm not just going to talk about Weldclass, even though I work for Weldclass. The interest of today's presentation is to talk about what's better for our industry. So therefore, a combination of controls from the hierarchy of controls may be required to address what's going on in the workshop. And this picture here shows one of our guys in a workshop with end users looking at their setup, looking at what they can do to reduce the fume in their workshops. And we're happy to go and do that. Now, I'll say that the people who work for Weldclass are not occupational hygienists, but we do know when we see a workshop that's in pretty bad condition for welding fume, and we have some very good solutions to address that. So isolate welding to booths away from other people, consider robotic welding in some cases, and let's face it, in today's world where competitiveness and cost structure is very important, robotics do help, including cobots. Engineering controls can also include a lot of other things other than just the things that might stand out with fume control, but coatings, paint, oil, mill scale, rust and metal coatings, zinc and galvanized, all those coatings deliver much more fume into the atmosphere. Using lower CO2 content shielding gases has been proven by the major gas companies such as Air Liquide and Linde and BOC to actually reduce visible fume and fume that actually goes into the workplace. And there's a certain amount of CO2 that you do need in an argon shielding gas to give you good penetration, but the gas companies are all over the top of that. So talk to your gas supplier. You can use lower fume generating filler metals like copper-free MIG wires and copper-free flux cord wires, lower fume flux cord wires, for example. So they have a different internal formulation in the powder. It's inside the wire that helps reduce the fume. You can compare different welding and cutting processes to consider lower generating processes. So MIG versus flux core versus sub-arc. So in sub-arc welding, there is no fume or very little. You can compare welding transfer modes as well using voltage and amperage settings that minimize fume. So obviously the higher the voltage and voltage and wire feed speed settings, and the higher resultant amperage produces more fume. So then comes fume extraction and evacuation, and then under the legislation becomes the thing of monitoring the air that we're breathing, so exposure level air monitoring. And it does say in the standard by a competent person, and that's open for a little bit of interpretation, but we would say you've got to have some kind of device to understand where the speedo is. And then in big firms or firms who can afford it, then definitely get a occupational hygienist or industrial hygienist in to confirm your findings. Records should be kept for 30 years, by the way, to save employers problems with litigation down the track. Okay, so this is the Weldclass range of fume mitigation devices using the hierarchy of controls. And so we have on-fume torch guns, we have fume extractors that go on those MIG guns with fume extraction, we have downdraft tables, we have LEV mobile local area ventilation extractors with the hoods, we have the PAPR helmets, and most new to our range is the All Clear PD30, the little device there down on the right-hand side. And that is what we're going to talk about today, and in detail, to show you how that can probably give people an indication of what the speed they're travelling at for welding fume. So fume monitoring provides confidence. Exposure level monitoring by a competent person, we talked about it earlier, but up until now, it's been a little bit of a hit and miss. Air monitoring is required, but the standard in the legislation doesn't say how, doesn't specify how. But we would recommend that you have to have something to know where you're at. Otherwise, you're going to get a expensive industrial hygienist in every week. That would be probably counterintuitive to your profit line. Not a shot at the industrial hygienists, by the way, occupational hygienists. I think they're required in this whole package here. So you've got to come up with a baseline and then get the occupational hygienist to actually measure that baseline and confirm it. Then you have a proper documented line in the sand. So if work safe ever do ask, you've got it. As I said there, we've had questions from small workshops saying, you know, what if we can't afford to continuously employ our occupational hygienists to check out our fumes? Well, you need that device. You need something to actually check it with. And I suppose any measurement is better than none. And the machines that have been on the market today have been giving us some clarity to how bad welding fume really is. And the Plymo Vent Error Guard, the Dust Light, are two examples that I know of in the market that people are using now, and it's helped with understanding the dangers of the fume. The new All Clear PD30 goes a little bit higher level than our competitors. So the All Clear PD30 is designed to give you a visual representation of the fume based on an 8-hour time-weighted average data live on the portable device. So that screen you're seeing over on the left-hand side is actually measuring and showing 8-hour TWA on the device. It's the first one of its type to be straight out of the box that you buy it out of. Plug it in, charge it up, clip it to your belt or clip it to your shoulder strap near your PAPR system, and it measures what's going on live. It's a first in the Australian welding industry, if not the world. Let's have a little bit more detail. Number one, it's actually made here in Australia. It's made in Melbourne, by the way. It does deliver real 8-hour time-weighted readings on the screen. It's very easy to read. It's a very visual inspection. It's great for not only the welder, but management, foreman, leading hands, etc. to walk around and see what's going on. It works on a 1-second air sampling rate with a high accuracy, which delivers 28,800 measurements over an 8-hour period, which again is next level compared to what's on the market today. It delivers over 400 million plus data log points are recorded. And again, no one else does that. It has a 12-hour runtime. So you get through your 8-hour shift and a little bit of overtime, which is fantastic. It's small, it's lightweight, only weighs 260 grams. It's got some nice belt and strap clips on the back, and stainless steel that allow you to clip it to your clothing or your belts. It's Wi-Fi connected to your mobile phone, and that's standard out of the box, and it's free. So all you need to do is turn the machine on, turn your Wi-Fi on, and go through the connection sequence, and you can see your data on your mobile phone. You can also connect multiple PD30s to our cloud platform and help then keep track of large and small workshops alike. And there is an annual subscription if you do take up the cloud platform. But just be aware the cloud platform allows you to view multiple devices. We're talking hundreds, if not thousands. And that way, a leader of a OH&S department can see what's going on in multiple welding bays on very large workshops or very large shipyards, for example, or even in welding bays and TAFE colleges. You can see the whole lot. So it offers a reliable first-level fume detection solution for end users and employers, and it's great for preliminary and guided testing. The PD30 device provides immediate guide to help a person conducting a business undertaking to start reducing their fume risk. And we suggest that you do get an occupational hygienist to carry out on-site gravimetric testing as well to confirm the baseline based on your fume exposure measurements using our device. The All-Clear PD30 offers multi-site, multi-user capabilities, providing easy and scalable reporting to very large and extra large enterprises. So not only would it work to have the portal, or sorry, the web app showing you what's going on in one workshop, but you can connect multiple workshops. So you might have an OH&S national manager based in a certain city of Australia, and they can see what's going on in Sydney, Brisbane, Melbourne, Adelaide, you name it. We're very happy that this device allows house safety teams to do that work, coordinate it, and then they can also then verify what's happening in those hotspots where they see shoot up in maybe in the level of fume, because the truth is that the welding jobs that come into a workshop day to day, especially in jobbing shops, are different. So you might have a project you're working on today and the fume extractor or the monitor is saying that it's well under the limit, but tomorrow a different job comes in and it's galvanized iron, and the next thing you know, it shoots up over the actual limit. So it's a very effective tool to measuring those spikes, which means someone can get down to the actual welding area and maybe put extra processes in place to reduce that fume to an acceptable level, bringing in more local area ventilators with the hoods and the arms, or putting in more natural ventilation, for example. So it's a great device to help people do that. This is a little slide just to show the difference between the Weldclass PD30 monitor versus using an occupational hygienist testing. And I won't go through every line by line, but just needless to say that we very strongly recommend that people in large business undertakings, large enterprises, still have an occupational hygienist do your testing, helping to use the PD30 to set that baseline. Happy to answer questions on this, by the way. The one point I will mention is that the incident readings in milligrams per cubic metre for the time-weighted average, we do have 3 levels on there for the particulate matter. 1 micron, 2.5 micron and 10 micron levels, and they are designed to look at the different areas of exposure to the lungs via inhalable and respirable particles. So it's a very handy little device. In actual fact, you can actually change this device to actually show you those PM1, PM2.5 and PM10 ratings on the actual portable device. No extra cost. So there, again, it's a more visual representation of what it looks like. After this slide, we're going to talk about more terminology in regards to fume exposure and the dangers of fume. So bear with us. How are we going for time? Pretty good. So it's colour coded. It's lightweight. The PD30 we've talked about. It's made in Australia, made here in Melbourne, and it's giving us the real time 8-hour time weighted average reading on the device. And that little photo there shows a little belt clip that's on the rear of the device, and there's also a lug or a ring that you can actually put a lanyard to put around your neck if you wanted to.
Andrew, we have a question.
Please.
Okay, so do you have a solution for the legislation change coming in December 2026 that puts wells on particular elements like manganese, CO and CO2, etc.?
That's a good question. So I'm actually addressing some of that in these next few slides, to be honest. So when it comes to some of those elements, there will be no solution other than basically to remove them or not have any exposure to those elements. So we'll talk about that in a minute. So the terminology, RPE. So if you look at the legislation, it doesn't talk about PPE. It talks about RPE, respiratory protection equipment. Talks about respiratory products, the small particles that can penetrate deep into the lungs, into the alveolus, typically down under 4 microns. Talks about inhalable, which are the larger size molecules. Then talks about PPE, workplace exposure standard. It talks about microns, obviously. TWA, time weighted average in 8 hours. Talks about the short-term exposure limit based over a 15-minute period. The STEL talks about the volatile organic compounds, VOCs, and obviously we're going to talk about the WELL, which is coming next year in December, the workplace exposure limits. And there's a bit of information in this presentation after these next few slides on the different types of filter mediums too for fume extractors. And one of the elements that were just mentioned in the question are basically non-threshold genotoxic carcinogens. So chromium-6, manganese, and other elements are now being classified into these NTGC areas. This just shows everybody a little visual graphic to understand the size of particulate matter particles that we're talking about. And that big grey thing there is a human hair, showing between 50 and 70 microns. And then you can talk about PM 2.5 fume levels, which are organic compounds, metals and dust. Look at the size of it compared to a human hair. So very, very small particles. You can't see it other than when it's in a voluminous cloud. In some cases you can't even see it. This shows the different levels of inhalable and respirable particulate, and shows the size again rated in microns. So 10 microns over on the left-hand side for inhalable, and that's kind of stuff that you would maybe, if you've been welding without fume protection, you might in a garage at home at night, you go to the shower and you blow your nose and you've got all the black stuff coming out of your nose from grinding dust, for example. That's inhalable size of particulate, and some of that would be welding fume too. The respirable stuff is the stuff that is the real danger, and obviously the ultrafine particles can be absorbed into the body, body wide, and that's the stuff we really don't want to have anything to do with, and even the very fine. Next slide. So yes, from the 1st of December 2026, the regulation limits will change. So new speed limits apply. And the workplace exposure standards will be called workplace exposure limits. So therefore, the terminology is changing, but it also means then that WorkSafe and employers and unions and workers know that that is a limit, and that's where it should not go past. Yeah, or shall not go past. So up until the 30th of November next year, the WES values remain enforceable, but from the 1st of December, you must comply with the WEL values. So it's not simply a rename. Some of the exposure limits of those metals that we talked about a minute ago will be reduced. Some have been increased slightly, and some substances will be added to the list, others removed, especially the non-threshold genotoxic carcinogens, the NTGCs. For the 33 listed NTGCs, a value that cannot be deemed safe cannot always be set. So under the WEL limits, you either need to eliminate them or substitute or minimise the exposure to those NTGCs as far as reasonably practical. So, and you can check out the change on or the proposed change on the WorkSafe Australia website. So part of the answer to the question earlier is in those particular elements that were mentioned, then we've got to get rid of them or make them so small in the fume cloud that it doesn't get to our people that are working with those metals. And no doubt our friends from WorkSafe will be asking for proof. This is a slide taken from the AIOH website, which is the Australian Institute of Occupational Hygienists website. And it just shows you the levels of differences between the current exposure standard on the left-hand side there versus what will be coming in as a WEL limit on the 1st of December 2026. So yes, we're looking at this very closely. It's a very good question that was asked earlier, because it does raise some concerns with engineering workshops and fabricators, welding workshops, and how do we handle it? As I said, the best way we can handle it is try and remove it or limit the exposure to the absolute minimum to our workers. So some of the nasty ones there are obviously nickel, manganese, and then chromium 6, hexavalent chromium. No exposure standard. So they want us to remove chromium 6 altogether. So we've got these nasty metals that we've got to deal with. So we've got to reduce the amount that goes into the air in our workplaces. And that leads into this slide about filter classifications. So at the moment, there's a lot of filters on the LEV portable devices that you see in a lot of workshops with the snorkel, with the hood. A lot of companies are using F9 filters in those devices. They filter down to about 1 to 10 micron range. And that F9 is basically it's a ISO classification for air filters in general ventilation. And it kind of fits loosely comparable to a P2 particulate filter from AS 1716. Obviously, they are two different standards, but if someone said to me, what does an F9 do? Does it give us a protection rating? Yes, it does. What is that protection rating? Well, the air that's coming out of the back of the machine is giving you a protection rating of about a P2 filter. So that means that the filters for 2026, December 26, have to get better, yeah? And that's one of the solutions that the suppliers like ourselves are working on. W3 was initially standard founded by DIN and the German Institute of Occupational Safety and Health. It was then rolled into ISO 21904, and it classifies filters in W classes 1, 2, and 3, 3 being the best. And it filters out about 99% of harmful pollutants. The MERV rating system from the US is also used and is sometimes confused with the HEPA standard, but it's not to be confused. They are two separate things. And then there's the HEPA system, which falls under EN 1822 and ISO 29463. And the best HEPA rating is a H14, which pulls out 99.999995% of particulates. So, and there's probably a move now in the industry to look at putting in different levels of filtration into these mobile extraction units and some of even the big fixed units. Yeah, so have like a pre-filter, you have maybe a W filter and then a HEPA filter at the last stage, for example. So because the truth is with the new limits, one filter solution, and I don't have the testing data yet to prove it, but a one filter solution may not do what's required. So a lot of work going on with us and other companies in the market, as in suppliers, to work through this legislation and also to work through our own devices to make sure that we can improve what we're doing today. This is a great little chart that just shows some of the different products that are being listed in the legislation and what minimum we should be using, as in the filter mediums, to filter those nasties from the workforce. So at this stage, the advice is for chromium 6 and nickel oxides to use a HEPA H14 and an activated carbon stage to remove the chromium and ozone. And basically, if you're using a PABR system, is to use a P3 filter with an A1 gas filter. So hopefully you people on today's webinar find that a useful little chart to give you some guidance. Okay, the the next slides after this one are basically an advertisement from Weldclass to show you more in depth the products that we supply to help the hierarchy of controls. So for those people who don't want to be inundated with our little sales pitch, we're happy to say goodbye and thank you for your time. And I might actually break for a minute and just see if there's any questions before we go into the next stage. More than happy for you to stay on, by the way, and we can see what Weldclass do supply in our range of fume control measures. No questions, Charlotte?
No, no questions.
Okay, I'll keep moving on. So as that slide said, if you're not too sure what's going on in your workshop, then reach out to Weldclass. We've got business development managers, technical managers in each state of Australia, except for Tasmania, but we can get down to Tassie, no problem. Give us a shout out and we'll be more than happy to come out and give you some advice. Remember, it's not occupational hygienist advice, but it's advice that's based on experience, based on real life situations. And hopefully we can help you get your fume problems under control. We do sell the stuff you're about to see through a national distribution network. We do not sell direct. So we're not going to come out to your workshop or premises and help you and then ask you for an order straight away, because we sell through distribution, including some of the big guys like Blackwoods and BOC SPW Group. And there shows some images of us in workshops with people doing bucket work, on a Blackwoods trade stand with our all clear product, out the front of workshops talking to the guys about fume extraction on LEVs, so the local area ventilation or local evacuation with the arms and the hoods. And of course, what's really getting very big now is mobile fume extraction. So getting MIG guns with the fume extractors built in, because it takes so much more fume out of the workplace by taking the fume away at the source. So we sell MIG guns to do that, and obviously the extractors to take the fume out of the workplace. So we do a Binzel style 36 MIG gun with Euro connector. That particular fume extractor has an automatic setup on it. So when you pull the trigger on the MIG gun, our MIG gun actually has a wire, it connects to the front of the machine. You pull the MIG gun, it starts the actual fume extractor. So the fume extractor is not going all the time. Additionally, if you don't want to buy our fume extraction MIG gun, you already have some, you can still use it with this device. And our device then comes with a little a magnetic coil that goes over your earth lead or around your MIG gun lead. I think it's best to go around the earth lead. And again, when the machine, when you power up your MIG gun and it strikes an arc, it turns the extractor on, and that runs off 240 volt. It's a good handy unit. Fits in a lot of workshops. It can actually, you can fit it to the top of most big amperage welding machines as well, big amperage MIGs. This is a similar system, but it is the most powerful on-torch MIG gun extractor on the market today. It's on 4 wheels, and it's we affectionately call it the R2 unit, the R2D2 unit. It's very good. It's made in Europe. It's a very good solution, and they are starting to move well for us.
Hi, Andrew. I have a question.
Yes.
The start of it's a bit long, but I'll read from the start. Our current workplace fume sampling is taken from the lapel outside RPE, which I'm advised is what the standard prescribes. We use fixed LEV and have recorded exceedances of about 110% well. Our welders wear AdFlow or supplied air helmets. When conducting static air monitoring at various distances from the welding to assess the exposure level to other personnel not wearing RPE, we do not see any exceedances. Hygiene team are proposing to add on gun extraction, which will add to work fatigue and is very costly. Is there a consideration for the protection that the RPE provides? I don't see the benefit of additional controls if our welders are passers-by are protected.
It's a good question, yeah, because the person who's written that is right. The legislation asks it to be close to the welding zone. It's actually not putting it inside the welding helmet. So I suppose what I would do is I would actually take measurements inside the welding helmet if you could. And that way you've got, again, another baseline to say, well, hang on, this is what we're getting outside the welding, the fume, I'm sorry, outside the welder's helmet. But because of the PPE that he's wearing, the PAPR welding helmet, which is forced air, by the way, then this is what we're recorded on the inside. So don't know if it's possible. It'll be very hard to fit our little device inside a welding helmet. But because our product's made in Melbourne, Australia, we can possibly talk to our factory and see if we can get an extension which would be made in the size of a microphone to put inside a welding helmet. Then we can measure it. What do you reckon, Mr. Technical Manager? Arnold's our technical manager.
If you're asking me, is the exposures like, possibilities and probabilities are also being discussed on those. It's not because you're wearing a PAPR, failures and effectiveness of those devices are, you cannot just tell that the ambient should be monitored first, because it's the probability of exposure of people that are wearing and people that might be wearing ineffective masks are also part of that protection mechanism. So it's not like you're sure that your PAPR is working, you're not exposed to the level. You need to monitor first the level so that you will be aware on what your exposures are. That's basically the monitoring PPE line comes into place. If you're, I don't know if that's clear or
yes. I suppose the question, it's a very valid question to say,
it is.
Yes, we're seeing what's going on outside the welder's facial zone, but we're not measuring inside the facial zone, and therefore he may be protected. And then when they've done the testing away from the welder, where other people are working, it seems to be fine. It's below the level. So maybe there's an opportunity for us to develop something in the factory.
Yeah, but remember the level, the exposure level is slightly ambient, right?
Yeah.
So people are exposed. So you need to monitor that. And eventually, as we are aware, the PPE is the lowest on the hierarchy.
Yes.
They want us
correct.
they want us to move further out of the PPE,
yes,
to go on engineering up to the top, which is the most effective.
Yeah.
Now, having said that, you need to monitor the actual environment, not the actual person. That's another option that you had, but you need to monitor the actual environment.
Yeah, you still need to. Yeah, correct, absolutely. But the question was that they've done that. They've done the monitoring, and they've now monitored. I believe this is right, Charlotte. Correct me if I'm wrong. They've monitored the work area, which seems pretty safe for their other workers. It's high. It's over the limit near the welding person, but is it over the limit for the guy underneath the hood? And that's the question. I think that's how it is. Have I interpreted it right? I think I have. So,
Bruce has also made a comment there as well. He said welders wearing PAPR will be well protected. Fume levels outside the helmet will be high. Standard and legislation currently do not allow sampling inside a PAPR, but it can be done.
yeah, I think it can be done too. So it'll be interesting because again, it would give an employer a good case to say, okay, we're doing the sampling, and this product produces this amount of fume over here, away from our other employers, that they're not being affected. And we know now that inside a helmet, this guy is protected. So that's where we've got to get to, I suppose. Otherwise, we're going to have some real problems when it comes to welding chrome moly steels and stainless steels. because we'll be banned from doing it. Have to import it from China. Okay, I'll go to the next slide. Downdraft tables. So we do a range of downdraft tables, and we do some other ones as well, not shown on this slide. So we do smaller ones, which at the top, that's a 240 volt version. We do larger units, which run off 3-phase. They have outlets at the front of that table, which is a 240 volt outlet that you can plug your angle grinder into, for example. And we also have another variant, which is got downdraft, but also backdraft extraction as well. So even better. Notice the warranty available on these products as well, very important. That's if you register online, you get the extra warranty and you'll get your 7-year warranty. We do the mobile LEV extractors, local area ventilation, and these ones are 240 volt units. We have a manual cleaning and an auto cleaning version. Manual cleaning meaning you actually have to plug a air compressor hose in and dust them out, whereas the auto one becomes a lot easier to maintain. And obviously they're dearer. And we have 3-phase units. Again, we have manual cleaning versions with 2 arms, and the auto cleaning version with 2 arms as well. So to either work around 2 operators, or it might be that the fume level from the welding application requires that amount of volume to remove the particle. And that is our last slide.
Does anyone have any questions for Andrew? Well, there's one here. Can you comment on maintenance and calibration of the PD30?
Good question. Maintenance is pretty easy. The actual device does come with a document that talks about the maintenance and calibration. Calibration should be, I believe, every 2 years.
It's recommended.
Yep, recommended.
It's
Yep, and that's in the instruction manual that comes with the device. And that's done by sending the device back to Weldclass, and we do the calibration ourselves here in Australia. Maintenance is basically don't get the item wet, keep them clean as much as you can, wipe them down, regularly. Look after them, don't drop them, don't smash them, don't throw them.
And also, the sampling technique is used by a cyclonic fan, so you don't have filters on them. So you don't need to replace filters, which is for other sampling like gravimetric, you need to maintain those filters for the pump. So that's the thing that we eliminated on the actual unit, filter replacement.
Yeah, good point. Thanks, Arnold.
We've also had a comment in relation to that previous question. So Brad has said, we can take measurements inside the RPE. However, because the standard calls for measurements outside RPE, hygiene won't accept them. We also monitor the work environment with ply movement air monitors and do not see high levels. I agree with your point around welding stainless. If the exposure limit is 0, measure XRP, then unless we can find 100% effective fume extractor, we won't achieve compliance. I think the standards need to reflect the protection the RPE provides.
Yeah, I agree, but I don't like the standard, but I agree, absolutely. And I think as the people on this webinar, and I'm sure some of you actually do speak to WorkSafe in your own states, and certainly Weldclass do, and I'm pretty sure that AWS do, and other suppliers in this country. So we should all, as a as an industry, be saying we need to have the allowance made for inside the actual the welding halls, because hey, we're trying to do the right thing and we don't want to hurt our workers and we don't want them to have exposure, but there needs to be allowance for it in the standard.
We have another question. Could you clean the filters with a vacuum rather than compressed air, as this might blow the dust everywhere?
That's a good point. I think you'll find that with our LEVs, we actually have a procedure in each of those units, and some will, they do use compressed air, but at the same time when you're doing it, the unit is actually closed. Otherwise, yeah, if you open it and do it, then it puts the stuff everywhere. So follow the maintenance advice in our equipment, and you'll have no problems.
Okay, we have a few more questions. This one just says, where is the sensor located?
On the PD30,
I'm assuming so.
yep, it's on the side.
Left side if you're facing the equipment.
Yeah.
And this one is for World Australia, maybe Bruce. Does World Australia have any representation on the standards committee? I think that is Bruce.
Yes, we do. I was actually typing out a reply to earlier, but I'll delete it. The allowance for sampling inside PAPRs is an item that has been raised by myself at ISO level and also elsewhere. The stumbling block apparently is, from what hygienists tell me, is that the sampling heads have to be calibrated, as you can all well know. But there is a calibration issue when the sampling head, for whatever reason, is used inside a PAPR. I don't know what the issue is, but that's what the hygienists have told me repeatedly. So, but we have, I've certainly raised the issue on numerous occasions about sampling inside PAPRs, because that is the obvious place it needs to be done if you want to know, are you protecting the welder with your PAPR? Now, the answer is yes, but we just don't know how well it's been doing. And I do know that there have been a number of people who have sampled quite successfully inside PAPRs.
Great, that's good to know. Thanks, Bruce.
Another question from Tennille, who asked about the sensor. He asked, and does it record and base the results on the recorded time period, or is it only real time?
Yes, basically the unit will log every minute for your aerodynamic sizes, average per minute, and also it will record your time weighted average an 8-hour period onto the device. That's the 400 million plus data log that we highlight in there. So you could download the file via CSV on your phone.
Okay, another question. Does Weldclass have a traceable calibration validation lab and process with, and is it accredited, e.g. by NADA?
We have our factory here in Melbourne. Is it a NADA approved laboratory? No, it's not.
Okay, another question. Who will be enforcing these changes and checking on workshops? What's the worst case if a workshop is found not under the limits?
Yeah, well, I can tell you some information based on experience and based on seeing and talking to fabricators in the Victorian market. So WorkSafe have been out into the market in country areas that I know of. So I've got some friends who live in a country town, a large country town in Victoria, and they've been in the workshops and they've seen that the workshop's got very little hierarchy of controls in place. They've seen welding fume hanging in the ceiling of the workshops, and they've basically given improvement notice straight away to the owner of those workshops and said, look, you've got 7 days to respond to how you're going to fix this, otherwise we're closing you down. So they're very strong and very tough about it. And if you've got fume hanging in your air, like the old pubs were with cigarette smoking back in the day in the 80s, then please call someone, call us, we'll come and help you.
Chris has also just commented here that effectiveness of the PAPR is also dependent on the type and maintenance of the filter.
Yeah, correct. Absolutely. And it's also, making sure that the filters are replaced when the PAPR backpack blower unit alarms and says that it's getting clogged, that you replace them. And I've seen cases where people in the industry will take out a cartridge out of the PAP backpack unit, smash it on the bench, and put it back in and use it for another couple of days. So obviously, there's always cowboys in the industry, but hopefully with responsible employees and responsible people, they do the right thing. And keeping those filters changed over regularly as per the requirements is definitely an important part of protecting the welder.
There was just another comment that says, apologies, but that's not how improvement notices work.
Well, that has happened, I believe, from one of my friends in the country. So unless it's a WorkSafe person on the call now, they can tell us how it works. I'd like to know.
Bruce has commented that Fume standards are being enforced throughout Australia, and Weld Australia's engineers can assist with guidance.
Yeah, absolutely. Yeah. So yeah, and again, I know of people who have received visits from Safe Work, and they've been very critical if the fabricator has not got PAPR helmets on their workers, and they're very critical if they don't have fume extraction. So there's been a real push that I've noticed for Safe Work inspectors talking about on gun fume gun protection as well.
All right, we're just about on time. Are there any further questions? Otherwise, thank you, Andrew, Weldclass, and thank you, Bruce, as well for some of the questions. I'm going to stop the recording. I will send this recording out to everyone that attended later this afternoon. So thank you, everyone, for attending, and thanks again, Andrew.
Thank you, everybody, and thanks for your attendance.